All right, so I'm live. I guess it's difficult to compete with dinner, but I'll try to make it through here all right. So this talk is about developing 3D printing applications and 3D print in general. I'd like to remind you that there's an evaluation form, and we'd like to have you fill it out when the presentation is over. With that, I'd like to launch right in and start out with our agenda. So 3D printing has changed quite a bit. There's a lot of opportunities that are presenting themselves at this time. A lot of tools that we're putting into Windows 10. We're going to go in depth about the things that we're doing in Windows 10 that really help the developer. And today we're going to announce and talk about the 3MF Consortium. 3MF Consortium is a group of companies that have gotten together to kind of help improve the file formats that we're going to be using for 3D printing in the future. And then my colleague Emmett will be coming up and talking about 3MF Consortium and the future of 3D printing. So with that, let's launch right into it. There's really a revolution going on in 3D printing. It's really a great time to be in this career because 3D printing has kind of moved from a very niche thing, a very expensive way of making things, to much less expensive. It works really well for doing short runs and one-offs. I've been visiting a lot of companies and I've seen a lot of what people are doing. For instance, I visited a company that was manufacturing for automotive industry, and they were making engine blocks out of aluminum, and they could turn them around in 4 days. And it was amazing to see that because in the past, somebody would have to make a mold, and then they would have to cast the engine block. The turnaround time for that was about 4 months. And so as they iterated through the engine designs, they found perhaps some area was hot, not getting enough cooling, and they needed to modify the design. They could get a very rapid turnaround. So it's interesting to think of it. Now, those weren't the engines that were used in production. Those are simply prototype and testing. What 3D printing is doing today, not just turning around the time, it's allowing you to do things that just could not possibly be done before. I was handed a carburetor, a throttle body. He handed it to me and I was shocked. It weighed just a few ounces because the entire inside of the structure was hollow. And that's something you just can't do with traditional manufacturing techniques. So there is a revolution in the making, and I think it's going to be very interesting what's happening. So I'm going to break this down into sort of two parts, because we have the desktop things that are going on, and then we have additive manufacturing, which is going on in the industry. So desktop printers, as you see here, this is a Cube 3 by 3D Systems. It's under $1,000. The plastic is relatively inexpensive, 50 bucks a kilogram. It really opens up. This is a little bit more advanced printers that you've seen because it has auto bed leveling and auto Z height. And so it's opening up 3D printing to more people than just the people who do this for a hobby and they know it inside and out and they want to learn it. It's opening it up for a much larger audience. The education, I was at high schools. I'm working with kids doing robots. And suddenly, you could see these kids visualize that they can rapidly innovate their designs. Even though it's just a high school competition for robots, they can rapidly innovate on their designs and they can see the possibilities where they're going with this. They can print the pieces that it takes to build a robot. And it's really interesting to see that there's a whole new generation of people coming up that are going to think very, very differently about how you do product design. 3D print bureaus, as we call them, manufacturing facilities, enables those that don't have printers, those people who don't want to futz with the printers, the ability to print from their desktop and receive something much more complex. So the print bureaus or the fabrication services, they can do very high quality parts. They can get down to 50 microns precision. They can do things that have strength better than castings. And you could do them in many, many materials, which suddenly takes this whole concept, oh great, what am I going to do with this plastic single color thing? It really opens up a lot of possibilities, specifically for developers who are developing apps that might be to customize existing things. So let's take a look at the opportunities for the developers. So There's lots and lots of things that I've seen out there. Everything from, I want a phone case, and that phone case I want customized. I want my logo on it, I want my name on it, I want my sport on it, my nickname. These things are very easy content to print and very easy to modify and customize for individuals. So there's entire industries springing up around, I'm going to print you a case that's of a specific material and that's customized in a specific way that you want to see it. And you could do this very interactively over the internet, send it in, have it manufactured by some third party, and deliver it. It's opening up a lot of opportunities for developers to move into right now. So the key is to find the content, to find the niche, and maybe not try to boil the entire ocean around 3D printing, but to incentivize the designers and to leverage the content that's out there to create specialized things for your customer, individualized things for your customers. So let's be clear about 3D printing. 3D printing is not always so easy. In the past, you've had non-standard driver stacks, you've had different slicers that you could choose from, you've had COM ports that you have to configure, you have open source software that you have to put together and work through, and that's not always so easy for my mother to do. So we need to really overcome some of these problems. Printers have a fairly low success rate. Like if you can get 50% success, really get what you're looking for, I think you're doing pretty good. And that's not really analogous to what you think of in the normal printing. It's a little bit lower success rate. So we have a ways to go in order to get these desktop printers really working. The other thing is, nobody can tell what the printers do. You can't get any information from your printer in terms of what are the materials. Like even on paper printers, you could tell what kind of paper it uses. But in a 3D printer today, you really have no information about what's coming back. What are the materials? What's the thin wall size? What's the bed size, the volume of the bed? And so this has really been blockers to entry in the past. So what I want to do is I want to talk about what we've done in Win 10 that will help solve some of these problems. So I got to start out with this first bullet, workflow. This is an interesting concept. We call it workflow, but I really need to clarify exactly what a workflow is. A workflow is the process of actually getting your print prepared to go to the printer. And so if you keep this context throughout the rest of this presentation, it'll be a little more clear what I'm talking about. So repair capabilities and APIs. Repair, we call repair, many other people call it healing or fixing, but what we call repair is fixing a model so that it can be prepared to print. A model could be filled with holes. If you had, for instance, an animation program, and that animation program had a bunch of cartoon characters in it, it doesn't have to be a solid model. It can be a facade. It can be just texture on top of a shape. And if you go to try to print something like that, it just doesn't work. When you print something, it has to be a solid object. And so this has been a major blocker as the industry has developed, is getting it printable. So we're putting APIs in the box that are going to do this for you. Also, another major driver is plug and play. If you don't have plug and play, and you have to do a bunch of configuration, especially around COM ports, to get things lined up, all of the proper things installed for your workflow to go through, it really becomes problematic. My mother is not going to do it. What my mom wants to do is plug it in and just have it work. I want to do file print. So this whole abstraction that we have around 2D printing, we really need to extend that into 3D printing. And then finally, there are a lot of people who just won't have these printers, but maybe they want to play with it or experiment with it and try it. And so cloud printing, we feel, is very important. Printers are expensive still, and the quality of the print, the difficulty it is to manage the print, really lends itself for people saying, yeah, I want to make this part, I need a customized part, but I really need it in metal, and I'm not going to go spend $300,000 to buy a laser-sintered printer just so I can do this one print. So cloud printing, we think, is a very important part of our strategy. Remember 2D printing about 20 years ago? I had to have a special driver for Lotus 123 for a specific printer. So you go to buy software, and the first thing you have to do is check and see if you've got the right printer that they have a driver supported for. It was ridiculous. Microsoft solved that problem. This is where we are right now with 3D printing, is we need to understand what materials, how it's, it needs to just work. Everything needs to be there, from the repair tools to the slicer. Everything needs to work in a row when you plug it in so that it's a file print experience. So we're going to talk about 3D workflow. Once again, let me go back and remind you that the workflow is the process from file print to actually the printing starting. Okay? So the file print experience, it's a very familiar dialogue. Everybody uses it in 2D printing, and it's a very good analog applying it here. You can select a 3D printer, or you can select a cloud printer. Unfortunately, with 3D print, it's a much more complex process to get through than it is with 2D print. So there's options for the printer, which is the same as in 2D. There's material assignment, which is kind of analogous to selecting the right paper to print on. But you also have to be able to look at your objects and to put them on the plate so that they print in the right place. There's a lot of different things to do. So I'd like to do a demo of Windows 10 3D workflow. Let's start by hitting the right button. God, I hope. Ta-da, okay. This is any app. I know it's 3D Builder, it's our app. But you could think of this as being any app at all. So I'm going to start, this is a touch app or a mouse app, either one you wish. So I'm going to start by just saying print, because the app really isn't so important as the print workflow. So here's the workflow. You notice my train and my wheels. There's multiple objects on the bed. And there's a few key things. You've got an arrow right in the top that's saying you're not on the bed. This print is not going to succeed because you're not on the bed. And an easy way to do it is just to click it, and it goes on the bed. Okay? I have another arrow up, but I'm going to talk about that one later. So I would like to look at this object first, so I'd like to spin it around like this and take a look at it. And yeah, it looks pretty good. That's what I want to see, upside down, right side up. One of the key things is there's a true expense with the volume of the print. And so perhaps I would like to scale the model and make it bigger, therefore more expensive, or smaller. And I can do that. I could do it to the point where it no longer fits on my print bed, and so I can scale it back down again. Okay? So that's important. It's important because of cost. If you're going to send this out to a print bureau, the bulk of the price is based upon the volume. And so if you go over to our scan booth and you get scanned and you zoom yourself up really big, you're probably going to pay $1,000 to get your little scan printed at the print bureau. So you might want to scale it down a little bit to be a little more affordable. You can get it down to the $25 range. But since it's volume, it goes up as a cube of the size. Okay? Other thing is, if I can move things around on the print bed to make them fit. If I happen to have them up off the print bed when they come on, gee, that's unfortunate. I would really like to lay it down on the print bed so you could just pop it right down onto the print bed so that you're not printing supports up to your object, which is floating in midair. So other things, there are some editing tools that we've left in here. The next thing that you need to do is you really need to tell it what material is. And since we have the APIs in the operating system that the workflow has the ability to understand the printer bed size and the materials, I can select this guy and I can say I really want to have a blue train. And then I can go to the selection tool and select all and then deselect the train and say I want my wheels green. Okay, so we think of color as a material. It's a property of a material. But you could just as well be saying, I want this gold or aluminum or whatever, and then when you send it out to print, it prints. And then finally over here on the left-hand side, you can see you could select the density. Now this information is coming back from the printer, is what is the density that it should be printed in, the density of the infill, the quality, whether it be draft quality or high quality, and whether you want rafts or supports on. If the printer had more capabilities, you would have more capabilities listed there. And then finally, when everything's done and your errors are gone, you just hit print, and off you go, and you print it. And off you go and print it. Okay? So that's a little demo of the direction we're heading with Windows 10. In Windows 8, we barely tolerated the printing. And now in Windows 10, we've really fleshed it out to give people control. So that's all really cool. But what does that mean to you as a developer? What that means is we've done the heavy lifting. You don't have to do a 3D viewing tool. You don't have to create the user interaction in order to view things and spin things around and look at it. If you're a very simple app and you really just want to print something, like I have a cartoon here, I like to print, Joe the Gunslinger, you really just need to throw that model over the wall to us through the file print capability, and then let us take care of the rest of it. We can repair it, we can scale it for printing, and we can select the materials to be printed or the colors to be printed, and then you can move on to either print it at a print bureau or print it locally. So the 3D content is all you have to do. Simplifies the UX, you get to focus on your core features, we'll take care of the heavy lifting around the print pipeline. But what if you want to do something a little more complex than that? So, for instance, if you might be a CAD application that you really want to have a great deal of control over what you're doing, maybe you don't want to just throw it over to our repair tool, because repair does change the model. And if you're a CAD app, you're probably very concerned about tolerances and the model being what you want. We're actually giving you a set of APIs. I talked in the workflow about the APIs. And the APIs to get information about the printer. What kind of material can it handle? What's the thin wall capability? We don't have all of the printer capabilities put into Windows 10 yet, but we certainly know the volume and we know the materials loaded in the printer, and so you can go through and do that selection. But if you're more like a CAD application and you really want to do the selection of the materials as a designer and then send those materials down, we give you the APIs to do that, to understand you can install your printer or you can install printer metadata and you can actually do that selection from your CAD application. When it gets to the print workflow, we'll get out of the way. We'll see, there's already printers, there's already materials selected, we'll back off. If your designer selects something less complex or that's not a printer material, you can edit it by making selections in the print workflow. We also are putting in the box validate and repair tools, because one of the big problems is the models aren't printable. And so it really is best for an advanced application, something that's not printing toys or something that you don't care so much about your shapes being modified. Sometimes these are just tenths of a millimeter to close holes, and sometimes they're bigger, like if you did a plain cut, or if you left the bottom of a model from a scan completely open, we would have to close that. So we're going to put the APIs in box to do that automatically so that you can access those APIs or you could access other APIs right there to get it fixed. And we'll automatically fix it, and we'll also send you back information about what we've changed. This is the single highest barrier removed. Okay? Cloud printing services. You can really make some fantastic things with the cloud printing services. So there's large companies who are actually putting desktop printers on the desks of their designers and engineers. And those large companies will print something in plastic, and they'll see that they fit, and they'll dry fit it into the assembly and make sure that's right, but ultimately they want something better. Cloud printing services enables. So we've partnered with Cubify, which is 3D Systems, and these are some of the things that they have available straight through file print. You can get professional materials, professionally done, and if you look at some of these things are not easy to do using traditional manufacturing methods. Okay? Driver development. We have 2 driver models. I'm going to go very briefly because probably not so many of you guys are doing driver development. We have a standard inbox driver. It works with a RepRap or a Marlin-based printer that accepts G-code. With this standard model, you don't have to write any code. It's in the box. It comes through Windows Update. And all you need to do is set the USB descriptors. There's 2 things you set. The first one is the MSO to tell it it's a 3D printer. And the second one is you pick a matching model that best matches your printer. Like if it's a Delta, you might pick a Delta. If it's a Cartesian, you could pick that. So we have a number of standard models that you pick and you say, I'm like that, but my bed size is different and here's my bed size. So no driver development necessary. You want to build a RepRap printer? You can have a driver that just works with Windows automatically. The other one is a virtual software driver. So what we've done is, in order to make the driver development simpler, we've made a driver that's a virtual software driver, and we put a little layer of a DLL on the bottom. And the DLL is something that you would do, and what it does is it takes information from the software driver and allows you to decide what topology you want to use, how to communicate with your printer, and if you need to make any transforms, like perhaps you have something unique about your printer where you need something that you have to transform, like you're sending blocks of G-code instead of individual G-codes or something like that. So there's 3 parts of it. You can add a custom slicer through a capability we call a render filter. You can add a custom interface through the DLL. You can also replace the workflow. Now, the workflow I showed you in Windows, it is completely replaceable. You can make a Windows device application that does anything specific to your printer, and as soon as your printer driver is installed, we'll back off completely and we'll call your workflow. As you drop down the printer selection, the workflow will disappear and your workflow will appear there. So all 3 of those pieces make it very customizable for your printer. You don't have to be G-code. You can have your own slicer if you think that's part of your IP. It just works. Because of these 2 driver models, you can go out there and you can see on the table today, there's 7 printers out there. Those are just the ones we have out there, but these are a number of those printers. This isn't all of them. We also very recently added Dremel and Be Creative. And so we have a number of printers that just work. Windows plug and play, and everything's included. Okay? So working with 3D data. So this is sort of the end of my part of the presentation. But what you see here in this chair is a very complex print. So Emmett is here to talk about 3MF format and the future design of where we're headed with 3D printing in the future. So here's Emmett.
Thank you. So, first off, who am I? Well, I haven't actually worked at Microsoft for that long. I originally got into 3D printing as a hobbyist. I've got in by making open source designs. If you've wandered around in the 3D printing world, you might have run across a few of the things I've made. You can find my things on Thingiverse. But in the process of doing design for 3D objects, I realized just how limited we were in the software, just how many problems there were actually making things work, making things get printed properly, and just in creating the things that you can imagine. And I was kind of excited to come to Microsoft because there was an opportunity to actually fix a lot of these problems that I saw in the world that we were all dealing with. One of the big ones, there's a lot of complaint out there about the file formats that we currently use. And we're trying to address that by actually making a new format. Now, you've got to have a good reason to make a new format, right? I mean, nobody wants extra formats just for the fun of it. But at the end of the day, there is a good reason here, and the reason is that there really hasn't been something truly for 3D printing before. The closest thing we had were a couple of formats, AMF and STL. STL is, I'm sure, well known to most of you. And And its deficiencies are well known as well. It's lacking all kinds of features. It's close to 30 years old now. It simply doesn't have the kind of data that we need. AMF has also tried to kind of address this, but they've had a different approach. And basically what happened was we were approached by our various partners from the 3D printer companies and CAD companies, and they told us, look, neither of these formats is solving our problem. We can't adopt these. We need something better, and here are our requirements. We said, all right, we're in a good position. We're in a place where we can talk to everybody in the industry. We're in a place where we can help to define good agreement and find something that's actually going to work, actually going to solve the problems and be feasible. So, there are lots of other formats to look at as well. Obviously, manufacturing is not limited to 3D printing, and the rest of the manufacturing world mostly uses CAD. They've got file formats, IGES, STEP are very common, but these are NURBS formats. And let me tell you, non-uniform rational Bezier splines are not for everyone. They're very powerful, but they're also very complicated. They're a high barrier to entry, and there's a reason there's only a few giant CAD companies that really push this kind of stuff, because they have the enormous investment and expertise to do that. But what we're looking at is trying to broaden this out to a wider set of developers, and that means using something simpler and more easily implementable. Now, a lot of what's been used in the 3D printing industry is actually sort of repurposed rendering formats. Things like OBJ, VRML, there's many more. And the problem with these formats is they're really not targeted at 3D printing. So they've got all kinds of great information about lighting and fog and whatever you might need for rendering, but that doesn't matter to us. What we care about is material. And material is a lot more than color. We're talking about metals, we're talking about strength, we're talking about conductivity, all sorts of things that just have no meaning in a rendering world. And in addition, a lot of rendered objects simply aren't real. They're meant to look all right, but fundamentally they're smoke and mirrors. They're not solid, and they're not something that any printer can create something out of. That's something that we really need to look at when we're doing our format that's truly for 3D printing. So what we've done is we've assembled a consortium, because at the end of the day, nobody cares if we do this alone. We need to work with partners. The whole point of this is to get broad adoption. That's the only way that a format is useful to the world. So we've partnered up. We've got leading partners in the CAD space. We're talking to Dassault and Autodesk. NetFab does CAD work as well. We're talking to middleware companies that deal with readying models for print and for putting together, for instance, the workflows to make manufacturing possible. That's places like Shapeways and NetFab. And we're also looking at partners in manufacturing. So SLM Solutions makes metal printers. HP is getting into the printing industry now. Autodesk makes their own. And the important thing of having all of these people involved is we make sure that we can actually have something that addresses everybody's needs and works for the whole pipeline, all the way from CAD to manufacturing, without needing any sort of retranslation or disruption of the data. And of course, what's really important is that this be an open format. I mean, realistically, the format is only worth something to all of these partners if it's broadly adopted. There's absolutely no reason for it to be proprietary. So you can go out online right now to our website, 3mf.io, and you can find our specs. And we are working to make sure that this is available to everyone. And to help adoption, we're actually opening up some open source code. So you will, I don't know if they're actually live just yet, but there will be links to GitHub repositories that have code under open source BSD licenses. And this is to help with file parsing, with read and write. At the end of the day, there's no reason to ask every one of you developers to go read our spec and go independently write a parser. That's a waste of time. So we'll do it once, we'll do it right, and we'll make it available. And this is a good way to make sure that we have a format that's consistent, that actually gets the data read properly in every place. And we understand that this is how we can make something that's actually useful for the industry. Now, when we go through creating 3MF, of course we're looking at the other formats and we're saying, well, I've talked about the deficiencies, so how are we going to fix that? Why is 3MF going to be different? Well, we basically have to take all the good parts of the other formats, remove all the bad parts, and add our own things that we think are truly unique and really important for 3D printing. So first and foremost, it needs to be complete. You can't have external references floating around that get broken every time you move a file. This is something that I've dealt with too many times to count. We use a common method, open packaging conventions, that basically allow us to have a package that contains any number of files we need. It has clear relationships. It has ways to basically keep all of the data organized. And finally, we also need it to be compact. So this is a zip package that helps to make sure that the transfer is fast and efficient. But internally, we also have to avoid duplications. We make strong use of references. We make sure that our vertices are not repeated. We reference them. Our objects are not repeated. We can make multiple copies and reference. These things are really important for keeping the file size reasonable, keeping the parsing speed up. And then we also decided it was important at the end of the day that this be a human-readable format. Looking around at what formats have really been adopted well, this turns out to be important. I mean, you know as developers that you need the ability to actually go through and error check and debug, and dealing with a giant binary blob is a huge problem. By using XML internally, we make this format largely self-documenting. You can read through it. You can see what somebody meant. And we have lots of tools available to deal with this kind of thing. It's a very well-understood standard. We will make use of binary formats when that makes sense, but we'll use well-known ones, things like PNGs and JPEGs that store data in very well-known ways. Because certainly there are times with rich data where you don't want to just write everything out in English. But there are some other important considerations here as well. The extensibility of this format is really key. We made the core specification as minimal as we could. So that basically this is sort of an STL replacement that can do all of the most basic things that basic printers need and basic CAD apps use, and you don't have to think about any of the more complex stuff. You have a very narrow set of things that you need to implement, and it's a short spec, it's an easy read, I promise, I helped write it. But we need to make it extensible because even though we know a lot of the features we need now, we can't possibly know all the features we'll need in the future. So we actually make use of XML namespaces to have a really clear extension model. So you can have a new namespace for your extensions, and you can make it clear at the beginning of a file, hey, I've got this extra information. And you can, as an app, make it clear whether you understand that or not. And if you don't understand those, if you haven't implemented those kinds of extensions, you can just wipe them out, ignore them. You don't have to do any extra processing. You can just drop down to the minimal core spec or whichever set of extensions you do understand without actually losing the ability to process the file. We already have created one extension. We call it the Materials and Properties extension. You can find it on our website. And that's to handle all of these things like color, when you're looking at things that you'd expect from a render format, especially when you're talking about sending things to a print bureau that can do full color. This allows us to have things like vertex colors, texture maps, material definitions, even composite materials, all the things that you would expect and need. And they're in clear ways that we can easily transfer from existing file formats into this one without losing information. But maybe the most important thing that separates this file format from others is that it is unambiguous. And this is really the key that separates us from the file formats that have come before, especially these rendering formats. To be a true 3D printable file, you have to be solid. You have to actually represent a volume. And this is a mathematical concept, and it is not a simple one. And it's been a big difficulty because the words like manifold and oriented and watertight are thrown around all the time, but they're actually rather poorly defined if you poke into them. You'll notice that in different places, they use different definitions depending on what their actual application is. We've gone through and looked at the 3D printing application and found very specific definitions that we know will work for this. So it's clearly defined in the spec. It's clear how to verify it. This is, again, part of our what'll be in open source code to make sure that anyone can verify a 3MF and verify it consistently. And then, of course, using that connecting back to, for instance, the Windows APIs, where we can now repair a file and ensure that if you had a problem coming in, maybe it was from a rendered object that was not in fact closed, we can guarantee you a manifold output that will really print solid. So, the other part of this is, what about self-intersections? This is fundamentally ambiguous. You can have an object that intersects itself, and there's not really a good way to avoid it a lot of times. This is actually very common coming out of design apps. And the question is, well, okay, so now what's the inside and what's the outside? When we actually, again, have a very specific rule that's easy to handle in processing that allows you to remove all ambiguity from that. So even if you have a self-intersected file, you know that any printer will choose the same way to represent that as a solid object. Now, that's all well and good, but most of that is things that have existed. Fundamentally, this is a triangle mesh format. We've seen these before. It's nothing crazy. It's nothing out of the ordinary. We're just, we're nailing down those specific things that help to make sure that it's really going to work reliably for 3D printing. But what's really interesting to me, at least, is that we can do something much more exciting in the future. What's amazing about 3D printing is you can now fabricate things that simply were not fabricatable before. You can look at pictures like this. We can build microstructures. We can build, these tiny little detailed pieces, hollowing out objects, making more efficient structures. There's printers that can do material gradients. Like you can actually continuously change a material, like the mixture of an alloy or the mixture of a composite across a part. So suddenly you don't have these sudden junctures where you go from stiff to flexible and have your part tend to break there. No, now you can smoothly transition that across. Well, we've never been able to do that before. And what this means is that we've also never been able to design these before, because what's the point of designing a part that's not possible to make? We have all kinds of amazing CAD tools that exist, but they're actually not made for this kind of thing. So we now have this huge opportunity for the developers to think about, what can we do to enable designers to take advantage of what 3D printers can now do? We need tools that simplify this immense complexity. We need ways to actually take, inspirations from nature, for instance, where you have these incredibly complicated designs, things that are fractal in nature, but they're that way because they are optimized. They are the best shape for the problem that they are solving. We can take advantage of that in our engineering designs as well, and even in our product designs, just to make things more beautiful. You can look at generative design, where there's whole new paradigms possible, where instead of saying, I'm going to design this by taking out my calipers and measuring and making it just this shape, you can step back and say, well, wait, really? I'm trying to solve a problem here. I'm trying to hold up this weight. I'm trying to resist this kind of motion. Maybe I can represent something like that and actually have algorithms and computers design the part that does that well, that conforms to my constraints and can create these incredibly complicated objects without my having to specifically place every facet. That's why there's so much possibility here. You look at nature for an example, and you can see that they're solving problems that we need to solve in engineering too. They're finding things that have incredible strength to weight ratios by removing material. They have high surface area to volume ratios if they're trying to create reactions and such. And they do this through fine microstructuring and methods that might seem random at first, but in fact are very highly optimized and solve their problem exceedingly well. We really don't have tools right now to do this effectively. These are the kinds of tools that we need to create. And when you look at this, we're in this really funny position where the hardware has actually exceeded the software, which, seems crazy, right? The software developers, oh, Moore's Law, whatever, we can beat everybody, right? But hardware is suddenly coming along and saying, hey, complexity is free. We can build as complex a part as you want, and the only price is the volume of material that you've put into the print. Well, sadly, that's not true for us. Computation is not free. Developing algorithms is not free. And we're to the point now where even though the printers can print these incredible things, we don't even know how to make them. We don't even know how to transfer the data. I've talked to designers who are on the leading edge of this stuff, and they're creating files in traditional formats that are terabytes. And that's just not feasible. We have to do better. So that's where we're going with 3MF. We know that we need to fix this problem on an interchange level to allow you as developers to fix this on a design level. And so we're working on new methods of organizing data that are actually unique, stuff that's truly new, truly different, so that we can actually represent microstructures in an efficient way, so that we can do this stuff and actually create new methods to look at data, and in so doing, create new ways of actually operating on that data more efficiently. So I'm really excited to be working on this, and I hope you all stay tuned for the stuff that we have in store. I can't release it yet because it's not ready. We have to prove that it works. We have to make some software that actually proves that our designs are good, that they'll really do what that we claim they'll be able to, and then we will release details to you when we've got the consortium all agreed. And the nice thing about this 3MF ecosystem with all these companies involved is that now you don't have to worry. You've got one format all the way down the pipeline from design to print. You never have to worry about loss of information. You can close the design loop. You can take that file that was just printed, and that's ready to go right back into a design program. You haven't lost anything. If you need to change something, it's there. You don't have to run back up the pipeline and try to find the original designer. And that's really important, because right now that's a big problem. And finally, just having an industry-backed consortium is really important, because it means that there's a lot of these implementations that are already existing or in progress by these companies to support 3MF. And it's not limited to membership in the consortium. I mean, we will invite other people to come as members as they come and ask us. But more importantly, it doesn't matter. Anyone can use 3MF. The consortium is more about driving the standard and all of that. But fundamentally, this is a format for everyone to use. That's why it's open. So, finally, as our call to action, if you're an app developer, we've talked about all these 3D print APIs in Windows 10 that you can call to easily do file print, allow your users to target not only their own local printers, but also the cloud printing services. So we'll be putting those up on MSDN soon. For the hardware manufacturers, we've got our 3D Print Driver SDK. We're going to be updating that with all the latest stuff that you've seen in the presentation. That'll be available online as well. Standard driver description and such will also come up on MSDN shortly. And finally, for everyone at all ends of the spectrum, if you're processing 3D content, I would encourage you to take a look at our 3MF core and extension specifications on our 3mf.io website. And you'll be able to find all the information you need, and of course, contact us if you have questions. So finally, evaluate the session, please. If we'd love to hear your feedback about what we've done. And that's all I've got. So does anybody have any questions?
Well, it must have been a pretty clear presentation.
Oh, no, we got one.
Oh, there we go.
We're working on scanning technologies to make sure that scale and the rest of that comes through with scanning before you 3D print.
Yeah, so as you can actually see at our booth, we are working with 3D scanning. We've got the Connect V2. We showcased Connect Fusion through our app 3D Builder, which is free, and we just made that so that it would be easy for people to use a 3D scanner. And of course, we can then create 3MFs in full color. You can send them up the pipeline to get printed in full color by the cloud service. So we're really excited about 3D scanning, but of course you can do it with much more than just the Connect. And it'll be exciting to get more of those pipelines coming in.
Hi. Hi. Hello.
Hello.
Is that working for you?
Yep.
So I'm a student. I'm in college now, and I'm mostly in software, but I'm the acting mechanical engineer for a project, a capstone project. And one of the big pain points with 3D printing that I have is clearances and tolerances. So I specify in a CAD model I want it to be ½ an inch. It comes out either 0.48 or 0.52, and I try to thread it with I put a rod through it or a screw through it, and it doesn't work. Is that a thing that could be fixed in software?
Yeah, that is. In fact, that's one of the key things that we're putting into the material spec. It is not in the Windows 10 material spec, but it's not just about the material. That part is probably shrinkage, and so as some of the materials shrink, they suddenly don't work. They don't fit anymore, especially with like ABS plastic. And so one of the materials that we're talking about putting in the material spec and working with the print companies is what's the shrinkage, so that you could build it too big so that when it shrinks to the right size. So as far as being too big, I don't know what would cause that. That's a little interesting, probably just your printer is off. But shrinkage and thin wall, inner wall spacing, all of these capabilities, we're trying to pull the industry together so that the printers can actually describe them, especially the professional printers, can describe exactly what their capabilities are and what we need to do to compensate for variations like that.
Yeah, obviously you'd love the printer drivers themselves to be able to understand this and compensate on their own, and I'm sure they'll be moving in that direction. But part of the reason that we make these print capabilities available to apps is so that if you want a very powerful app that can get you the absolute best results on certain kinds of printers, you'll be able to pull those capabilities out and do operations that you understand as the app developer will actually increase the quality of the final product.
Thank you.
Hi, so we have an application that outputs STL data. I'm sure you'd recommend that we replace that with a 3MF
Yes.
data format. But will there be any standard tools or Windows support for doing conversion from STL to 3MF?
So the way we look at it actually is from an API perspective. We simplify it by just basically saying you can put in a vertex and a triangle as something more generic, more like your internal representation of the data. And that can be packaged automatically by the APIs into a 3MF. And that way, we worry more about the actual data representation that you're using in your program rather than going from one on-disk format to another.
Okay, thank you.
Okay, well, if there's no more questions, certainly appreciate you coming. Please fill out your survey, and see you on the 3MF website.
Thank you.